Hello and good morning to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss a very important problem in synchronization that is called as bounded buffer problem. Bounded buffer problem has in it a buffer of a definite size. So here I have a buffer of size n. This buffer is supposed to hold item during transaction between different peers. Bounded buffer problem has in it a producer. It has in it a consumer. Producer is responsible for producing an item and placing it onto the buffer, whereas consumer is responsible for selecting an item from the buffer and suitably consuming it as and when required. So this is the way how the bounded buffer problem is oriented. Now let us go through a detailed explanation of bounded buffer problem. Bounded buffer problem is also known as producer-consumer problem. So again I'm repeating it, bounded buffer problem is also known as producer-consumer problem. Here there is a buffer of size n and each location in the buffer is capable of holding one item. So bounded buffer problem has a buffer of size n where each location in the buffer is capable of holding one item. There are two processes, namely producer and consumer. As discussed before, producer produces an item and places it onto the buffer, whereas consumer selects an item from the buffer and consumes it based on their own suitable time. Now producer tries to place the item to an empty space in the buffer, whereas consumer tries to consume the item from a filled space in the buffer. So producer tries to place the item to an empty space in the buffer, whereas consumer tries to consume the item from a filled space in the buffer. Now let us try to go through some of the strict impositions on this particular problem. Now imposition number 1 says producer should not place an item to the buffer when it's full. So producer should not place an item to the buffer when it's full. Likewise, the consumer should not remove an item from the buffer when it is empty. So producer should not place an item to the buffer when it's full, whereas consumer should not remove an item from the buffer when it is empty. And the most important imposition is that the producer and the consumer should not act simultaneously, or they should not perform operation at the same time. So these are the three important impositions guiding the operations of producer-consumer problem. So producer should not place an item to the buffer when it's full, consumer should not remove an item from the buffer when it's empty, and producer and consumer should not act simultaneously. Now let us go through a very simple strategy formulated for solving the bounded buffer problem. So here, in order to perform operations in mutual exclusion between producer and consumer, we will be taking into consideration certain semaphores. So the first semaphore that we will be taking into consideration is mutex. So mutex is a binary semaphore which provides mutual exclusion for access to the buffer, and it's initially initialized to value 1. So mutex is a binary semaphore that provides mutual exclusion for access to the buffer pool, and it's initialized to value 1. So producer and consumer will be validating the value of the binary semaphore mutex to decide on whether or not to perform operation on the buffer. Again, I'll repeat it. Producer and consumer will validate the value of the binary semaphore mutex in order to decide upon whether or not to perform operation on the buffer. Now likewise, there are two other semaphores that are taken into consideration. Both of these semaphores are counting semaphores. So we have learned that counting semaphores are used in situation where we need to keep track of the number of resources or different instances of resources. So here empty and full are two counting semaphores that are used in order to keep track of the items that are there in the buffer. So empty is a counting semaphore that counts the number of empty spaces that is there in the buffer and is initialized to value n. So initially we are assuming that the buffer is completely empty and the producer produces an item and places it onto the buffer, and then the consumer consumes it. So the assumption is that initially the buffer is empty. So that's the reason why the counting semaphore empty is set to n. So empty is a counting semaphore that keeps track of the number of empty spaces that are there in the buffer and is initialized to value n. Likewise, full is also a counting semaphore that counts the number of filled spaces in the buffer and is initialized to value 0. So initially, as we are assuming that the buffer is empty, so if the buffer is empty, then the value of the counting semaphore full will be 0. So it should be initially 0. So that is the reason why it is set to 0. So empty and full are two counting semaphores that are used in order to keep track of the number of empty spaces and number of filled spaces in the buffer respectively. So this is the way how the strategy is being formulated in order to perform synchronization between the producer and the consumer process. Now let us try to go through the producer process and let us try to understand it. Now the producer process is defined in this particular manner. So as we all know, in the previous class we had discussed wait and signal. Now the implementation of wait was, so wait semaphore S. So while S is less than equals to 0, perform no operation. Once the condition is not satisfied, that means when S is greater than 0, then the value of S will be decremented by 1. So that is the way how the wait operation was implemented, if you remember. So wait was defined as wait semaphore S. So while S is less than equals to 0, perform no operation. Once that condition is not satisfied, so you come out of the while loop and you decrement the value of wait by 1. Whereas signal was implemented as signal semaphore, so S, so where the value of S was incremented by 1. So wait and signal was used in order to decrement and increment the value of the semaphore, right? So if you recall and remember, that was the definition of wait and signal we had discussed in the previous class when we had discussed semaphores. So and we had also learned there that wait is a function that is capable of validating the value of semaphore, right? So here wait and signal is used in order to perform operation on the binary as well as the counting semaphore. So now let's try to understand producer process. So producer process is defined in this particular manner. So here first an item to be placed onto the buffer will be produced by the producer. So the producer produces an item that is to be placed to the buffer. Then the producer validates the value of empty. So in order to place an item onto the buffer, there has to be some empty space in the buffer. So if there is an empty space in the buffer, then the value of counting semaphore empty will be greater than 0. So here the value of the counting semaphore should be greater than 0 if there is an empty space in the buffer. So that's the reason we are executing a wait function. So wait function will validate the value of empty counting semaphore. So if empty is greater than 0, right, then what producer will do? Producer will attempt to perform a wait operation on mutex. So as we have learned that mutex is initially initialized to 1 in order to facilitate someone to have a exclusive access to the buffer. So wait will perform an operation on mutex. So mutex is initially initialized to 1, right? So mutex, so if that condition if the condition that is there in the wait is validated, so condition will be while mutex is less than equals to 0, perform no operation. So since mutex is 1 here, so it will come out of that particular while loop, and then it will decrement the value of mutex by 1. So when it decrements the value of mutex by 1, it gives an exclusive privilege to the producer to place the item onto the buffer. So mutex will be validated by wait. So upon successful validation, it grants an access to the producer process, right, to lock that particular buffer and perform an operation on that buffer. So that is the way how mutex will be validated by wait. So wait function validates mutex in order to check whether an exclusive privilege can be given to the producer, or exclusive access can be given to the producer to place an item onto the buffer. So once an exclusive access is given to the producer places an item to the buffer. Once an item has been placed onto the buffer by the producer, then what it can do is it can release that particular buffer. So now signal will increment the value of mutex by 1, right, which allows other producer or consumer to produce an item and place it onto the buffer, right, and then it will increment the value of full using the signal operation or signal function. So it will increment the value of full by 1 because it has placed one item onto the buffer. So now the counting sum of full has to be incremented by 1 because there is one less space that is there in the buffer. So that is the way how the producer performs its operation, and this is the way how the producer process is defined. So again, I'm repeating it. In the producer process, the producer first produces an item to be placed onto the buffer, then it will execute a wait on empty to validate whether there is an empty space on the buffer. Yes, if there is an empty space on the buffer, then what it will do, it will decrement the value of empty by 1 because now it has to place one item onto the buffer, right? So in order to perform the placement of item onto the buffer, it will execute a wait on mutex because it has to be given an exclusive right to the producer has to be given exclusive right to the buffer. So it will execute a wait on mutex. So it will decrement the value of mutex by 1. It will enable producer to place the item onto the buffer. Then once the item has been placed onto the buffer, then a signal will increment the value of mutex in order to make provisions for other producer or consumer to perform operation on the buffer. Then it will increment the value of full by 1 because one item has been placed onto the buffer. So this is the way how the producer process works. Now let us move on to the description of the consumer process. Now as compared to that of producer, consumer performs a validation on full, right? Okay, so only if full is greater than 0, then consumer will be allowed to consume an item from the buffer. So this is an important imposition that we have already learned. A consumer can consume an item from the buffer only when there is an item in the buffer, right? Okay, so first consumer has to validate whether there is an item on the buffer. So in order to validate that, it will check the value of full. So full should be greater than 0. Full should be greater than 0 in order to enable consumer to remove an item from the buffer. So it will execute a wait on full to check whether full is greater than 0. If full is greater than 0, right? Okay, then what it will do, it will execute a wait on mutex because the operation has to be performed in a mutual exclusion mode. So it will implement a wait on mutex, right? Okay, so mutex is 1, right? So it will be decremented by 1 in order to give an exclusive privilege to the consumer process. So once an exclusive access is given to the consumer process, the consumer will remove the item from the buffer, right? Then once an item has been removed by the consumer process from the buffer, then what it has to do, it has to make provisions for other producer or consumer to perform operation on the buffer. So for that, what it will do is it will increment the value of mutex. So it will release the lock on it will release the lock on the buffer by incrementing the value of mutex. So mutex will be again incremented over 1, enabling another producer or another consumer to perform operation on the buffer. Likewise, it will increment the value of empty because it has consumed one item from the buffer, so it has to increment the value of empty by 1. And then eventually the consumer will enjoy the item that has been removed from the buffer. So this is the way how the consumer process is defined. So consumer will perform a wait on full to check whether full is greater than 0. Only if full is greater than 0, it will be allowed to remove an item from the buffer. So it will execute a wait on full, right? So it will decrement the value of full by 1. Then it will execute wait on mutex. So in order to get an exclusive privilege or exclusive access to the buffer, so once an exclusive access is given or granted to the consumer, then it will remove the item from the buffer. So then in order to facilitate any other producer or consumer to perform operation on the buffer, so it will execute a signal, right, to increment the value of mutex, and then it will increment the value of empty by 1 in order to know that one item has been, or in order to make other processes know that one item has been removed from the buffer, or there is one less item in the buffer. Then the consumer will enjoy the item that has been removed from the buffer. So in this particular class, what we have learned about is we have learned about bounded buffer problem, which is a very important problem in synchronization. We have gone through the explanation of the bounded buffer problem. We have learned that bounded buffer problem is also called as producer consumer problem, where there is a buffer of size n that's capable of holding items. There are two processes defined on it, producer and consumer. Producer produces an item and places it onto the buffer. Consumer consumes the item from the buffer. So we have also learned about the impositions on the bounded buffer problem. So we have learned that there are 3 impositions. The producer should not place an item to the buffer when it's full. The consumer should not remove an item from the buffer when it's empty. And producer and consumer should not act simultaneously. So they cannot perform operation at the same point in time. So in order to formulate the strategy, we had considered 2 types of semaphores. The first one is a binary semaphore, mutex, that gives exclusive privilege to either producer or consumer to get into the buffer. And then we have learned about 2 counting semaphores, empty and full. And then we learned about the producer process, the way how it works, and we moved on to the consumer process, and we have learned the way how it works. So in the next class, we will continue with the rest of the problems in synchronization. Till then, thank you very much. Have a good day.